In this video, we are going to go over naming ionic compounds, part 3, about our lovely transition metals. Remember, those transition metals are in the D block, and they are rule breakers. They do not like to follow the rules. So there are some exceptions, and they can have multiple charges. Well, most of them can have multiple charges. So anywhere in here, they can have multiple charges, and you need to be familiar with that. Also, there's a few over here, these three right here. They can also have multiple charges. So even though they are not in the transition metal block, they act like transition metals and can have multiple charges. There are a few in the transition metals that do not have multiple charges. They make a little backwards L right there. So zinc can is always a +2, so it doesn't actually get the Roman numerals, which I keep talking about Roman numerals, but you don't know what I'm talking about yet. So just realize that these three right here are exceptions that we do need to memorize. So when you are naming ionic compounds with transition metals, they can have multiple charges. So the name must identify the charge. The exceptions to that are these, because they always have these charges and it doesn't change. So just kind of memorize those. In order to get the charge, it has to be given to you somehow. Well, because ionic compounds have only one ratio in which they form, inside this formula, we can get our charge. In order to do that, you have to look at the charge of the nonmetal, which is Cl. Cl has a -1, but I have two of them, so I'm just going to write them out twice. Now for Cu, I only have one. There's nothing there. And overall charge has to be 0. So if I have a -1 and a -1, I need to know something plus -1, -1 will give me 0. And that's going to make our copper be a +2 to cancel. That charge we have to show in our name. So we write copper, Cu, we write the word copper. And the only thing that we do differently for transition is we have to put the charge in Roman numerals following the metal. So the charge is 2. To write Roman numerals for that, it looks like that. And we close our parentheses, and then we name it like normal. So the chlorine becomes chloride. So this Roman numeral represents the charge of the metal. You have to provide that unless it's one of these three. So let's do this one. This is a transition metal. We don't know the charge, so we have to really break this formula apart to figure out my charge. There's 2 oxygens. I'm going to write it 2 times. If you look on the periodic table, oxygen has a -2 charge. So overall, I have a -4. Well, Mn, there's only one of them. I need a +4 to cancel it. There's only one, so it must be a +4. So when I write it, I write manganese, Roman numeral 4, oxygen changes to oxide, and it looks like that. I'm going to do one more, and that one more will be this. I had to think about that one. Okay, so we're going to, again, break it apart. S has a -2 charge, but there's only one of them. So my overall negative charge is -2. For cobalt, I actually have 2 of them, but I need the overall charge to be +2 in order to cancel. We'll have to divide that equally amongst however many I have, which means each one has to be a +1. So this would be cobalt 1 sulfide. All right, again, I'm going to pause it to write down some practice problems that you're then going to practice. All right, I want you to write the name for these 3, and I want you to practice some formula writing with these. So just remember that this Roman numeral 2 means chromium has a +2 charge because it's a transition metal. So work out these and then get checked off by your teacher, and then you'll actually move on to the Ozobot practice that we have prepared for you.